Okay, let's now work 6.39 from the textbook. This problem asks us about an aluminum engine part. It says, is this aluminum engine part, it's 295 grams. It's going to absorb 75 kilojoules of heat. If the initial temperature of this engine part was 13 degrees, what will the final temperature of this engine part be if the specific heat of the aluminum is 0.9 joules per gram per degree Celsius? Okay, so to solve this problem, I think we have to recognize first that it involves heat transfers or heat flows. We're told how much heat is involved. In fact, it's 75 kilojoules of heat, which is 75,000 joules. Now I've converted to joules immediately here, recognizing that my specific heat for the aluminum is in joules per gram per degree Celsius, which is the typical unit. So usually you have to work through joules, or else you have to convert this to kilojoules if you really want. I usually find it easier just to convert my heat into joules. So I've done that here in one step. That's my Q. That's how much heat was added to this aluminum. But we want to know how much the temperature is going to change. So we want to know delta T, basically, what the final temperature is. This type of problem, I guess, would be useful if you kind of want to be an engineer and you need to know how hot your item is going to get. If you want to think about it that way, okay? Just for fun. Now, our C is our specific heat. That's 0.9 joules per gram per degree Celsius. It's the specific heat of our aluminum, which is what this part is made out of. And the only other thing that we need in this equation here is the fact that it's 295 grams. That's our mass. So we have our mass times our C, our specific heat, times our delta T. So it's that formula, or that very, very familiar heat transfer equation. Keep track of how temperatures are going to change, right? No big mystery from where that came from. So we plug in the values, and all we got to do is algebraically rearrange and solve for delta T, the change in temperature. And when you do the math on that, it works out to be 282.5 degrees Kelvin or Celsius, whichever one you want to keep track of, because this is a temperature change. It's not an absolute temperature. It's just how much the temperature changes. And of course, 1 degree Kelvin is the same as 1 degree Celsius. Okay, so it doesn't really matter what units you use. You can do Celsius degrees or Kelvin. It's the same thing because it's a change in temperature. Now, we want to compute the final temperature in Celsius degrees. So degrees Celsius is going to be the initial, which was 13 degrees Celsius, plus our increase in temperature, because heat was absorbed here. So we're going to add 13 and 282.5. That's going to yield an estimated final temperature of 295.5 degrees Celsius. So that thing is going to get pretty hot after all of that heat energy is absorbed.